Okay, so for those of you who are just tuning in, you might have missed my spiel that on this snow day I do not have my stylus, so I'm using the tip of my finger as my pen, so please excuse any please excuse any handwriting here. But okay, so let's compare the shifts looking at the equation. This graph is exponential, and because of the -2, it would actually shift right 2. And because of the +3 on this graph, it would actually shift left 3. So what we're doing is we're really comparing how do you get from +2 to -3. We would have to shift left 5 units. The next one is linear. So this one starts with a y-intercept of -1, goes to a y-intercept of +4, which would require a shift up 5. This next one is exponential. It does not shift at all. Here we see that it is reflected, and it shifts right 2 and up 4. All right. Tom invests $10,000 in an account that pays 8.5% interest per year. Write a function that models the value of Tom's investment over time. So you are going to use the equation y equals a times 1 plus or minus r to the power of t. A is your starting value, so y equals 10,000 times 1. And then we are gaining money here, so we're going to do plus the rate. Your rate is 8.5%, but we need to move the decimal place so that we have 0.085, because we moved the decimal place twice, to the t. Now this is the model. A model still has 2 variables in it, and then we want to answer the question, how much will he have after 3 years? That's when you plug in the 3. So y equals 10,000 times 1.085 to the 3rd power. And you can type that into your calculator, and you should get something larger than 10,000. All right, 25. A necklace is appraised at $6,300 if the value of the necklace increased at an annual rate of 7%. How much is it worth in 15 years from now? Okay, here they're not actually asking for a model, so you can plug in your time right away. So y equals 6,300 is your starting value. 1 plus, because it's gaining value. Move your decimal place for the rate, 0.07 to the power of 15, because that is your time. Type that into your calculator, and you should get something more than $6,300. 26. Sydney purchases a cell phone for $225. The value of the cell phone decreases by 15% annually. Notice it says decreases. That means that we're going to put minus in our equation. Write a function that models the value of the cell phone over time. So we do need a model in this one. Y equals 225 times 1 minus 0.15, because we are decreasing in value, to the t. That is your model, and then you can plug in your 2 for t after that. Type that into your calculator, and you should get something less than $225 because you are losing value. Okay, 27. Determine, here we go. Determine if each table represents an exponential function. If it does, generate an exponential equation. Okay, we are looking for y equals a b to the power of x. Okay, a is your y-intercept, or your starting point, and b is what you are multiplying by. Okay, so from 2 to 6, we multiply by 3. From 6 to 18, we multiply by 3. 18 to 54, multiply by 3. So that is the base of our exponential. And what is our starting point? What is our y-intercept? 0, 2 is our starting point, our y-intercept. So we have 2 times 3 to the power of x. All right, so how do we get from 40 to 20? You would multiply by A half from 15 to 20 is not a half. Okay? So if this is not the same as this, then this is not exponential. Alright, here 24 to 12 we multiply by a half. 12 to 6 multiply by a half. 6 to 3 a half, so on and so forth. So what we are raising to our exponent is 1/2. And what is our starting point? 0, 24. So 24 times 1/2 to the power of x. Now make sure that you're paying attention to where that 0 is, because it's not necessarily going to be at the top of your chart. You have to find where x is 0. Alright. Last couple things here. Number 28, you write using radical notation. So you are not evaluating this. You're not going to get a numerical value. You're just changing form so that it has a root in it. Raising something to the power of 1/2 is the same thing as taking the square root. So this is the same thing as the square root of 15. Write using exponential notation. So now instead of having a root, we're going to have an exponent. And cube rooting something is the same thing as raising it to the power of 1/3. Number 30. Simplify the following. This is when you actually want a numerical answer. So raising something to the power of 1/2 is the same thing as square rooting. So you have the square root of 49, which is 7. 27. To the power of 2/3. The root is in the bottom, just like a plant. So you're taking the cubed root, 27, and then the 2 is just like the blossom in the flower. So you're going to square it. That's out on the top. Cube root of 27 is 3, and 3 squared is 9 for the final answer. See, 25 to the 3/2. Again, the number in the bottom is your root, so here we are square rooting. No need to put the 2 in the root. It is implied for square root. And then the 3 is the blossom. That's what goes out front. The square root of 25 is 5. So we have 5 cubed, which is 125. Don't forget that your test is tomorrow. If you have any questions as you're going through this, please feel free to email me and I will try to get back to you as soon as possible.